Reviewing today's class, we considered a couple of situations. The first one being a situation where coefficient of friction everywhere is 0. We have a ball suspended from a thread resting against a wall, another ball suspended by another string cord thread in contact with the first ball, and we want to know what the forces are acting on the second ball. It has mass M2, so we asked to list the forces on M2, and pretty much everybody listed the forces: the weight, the normal force, and the tension. So we then drew a free body diagram. Now here's my free body diagram. Didn't originally have the pink projections and of the tension and normal force factor, but the estimates I got from the class were generally pretty good. We estimated an angle between 60 and 75 degrees for the tension, which is reasonable, so I just arbitrarily called that 70 degrees. An angle between 210 and 220 degrees for the normal force, and might as well label that. 270 degrees applies to the weight force, so normal force here. And that's all pretty clear. Okay, so we got the angles right, and I just drew some vectors here. Then I asked everybody to sketch their own figure. I think that was before I actually drew this. Sketch their own figure for the forces acting on M2, and estimate, based on the assumption that the weight is 100 newtons, estimate the magnitudes of the other forces. Now we got a variety of estimates, some better than others, but a lot of estimates. And we then looked at my diagram to see if it held water, and we found that it didn't, and that was kind of as intended. The problem with my diagram was that the component of the normal force vector in the y direction and the weight vector, which is in the y direction, were much greater. The total of these downward forces is much greater than the y projection of the tension vector. Since this is an equilibrium situation, that can't be. Tension has to be big enough to balance these components down here. So the tension vector, let's see, add this to this, we get a vector about this long. Tension vector is going to have to be way out to here. Okay, tension vector would have to be much bigger. And I can draw that with a different color, and that color doesn't contrast as well. So really the tension vector, well, the y component of the tension would have to be here, which means, of course, that the tension vector would have to come all the way up to here. So superseding the previous tension vector, we get a correction. But then we have the problem that the x component of the tension vector, which would be out here, is not equal and opposite to the x component of the normal force vector. So we have all kinds of problems with these diagrams that need to be resolved. So the task that I gave the class was to sketch these and estimate. I got some estimates. I also got some equations and some formulas. We're trying to estimate visually, okay? We're trying to develop the ability to visually reconcile the forces as they should be. And of course, this is going to take some more reconciling because of the inconsistency in the x components. And that process gives you a deeper understanding of the equations, as well as the ability to visually analyze a situation to see if it makes sense. In any case, we analyzed the vertical equilibrium of my original document, and we found that we estimated a net force of -60 newtons in the y direction. Clearly couldn't be right. the tension, the Y component of the tension is going to have to increase by that much. Okay, so we see why these estimates can't be right, and we get some idea of how to manipulate a diagram to begin to resolve some of the inconsistencies. The other situation is an object on an incline. The object has a mass, and say the weight is 100 newtons. Again, we have a force exerted at angle beta with respect to the horizontal, and we have an angle alpha of the incline, and we want to estimate these forces. So we say, okay, the weight is 100 newtons. What are the normal force? What is the normal force? What is the force F? What is Fx? What is Fy? And I left the magnitude of the force F up to individual students, and from that uncertainty, we're going to get a number of different diagrams, a number of different free body diagrams to reconcile and analyze. So we'll continue with this on a new board.